Hi, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. So in this session, I would like to present my concept on curl of a vector point function. So in the previous videos, we have seen the divergence of a vector point function and gradient of a vector point function. We know that del is a differential operator. Del means I bar dou by dou x. Del means differential operator I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. And del can be applied on both scalar functions and vector functions. Suppose if we apply del on the scalar function phi of xyz, then it is called as grad phi, and this is called the gradient, and the gradient is the outward normal vector to the surface. That is the physical significance of the gradient. Similarly, if del applied on the vector point f bar as del dot f bar as a dot product, then it is called the divergence of a vector point function. Del dot f bar, clearly the resultant is a scalar function. When you make dot product, del is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with f1 I bar plus f2 j bar plus f3 k bar. The value you will get dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, and it is a scalar function. The resultant is a scalar, and this is called the divergence of a vector point function. And gradient is a vector. It is always a normal vector to the surface. The normal vector to the surface will give the gradient of y. Del on applying on vector point function as a dot product, then it will call the divergence. The divergence means if v bar is the velocity vector, then div v bar will give the rate of outflow per unit volume. So you have many applications for a gradient and divergence in the field of mechanical engineering. And now I would like to introduce another operator, another definition, curl of a vector point function. We know that del is a vector point function. Del is called a differential operator. Del is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. And if del is an operator and f bar is any vector point function, f bar is any vector point function, and if you apply del on f bar as del cross f bar, if del is operated on f bar as del cross f bar, then it is defined as a curly f bar. And we write it as curl f bar, curly f bar, del cross f bar. If you use del dot f bar, it is called the divergence, div f bar. If you use as a cross product, then it is del cross f bar, that is equal to curly f bar. Suppose if f bar is f1 I bar plus f2 j bar plus f3 k bar, then the curly f bar is a del cross f bar. So the cross product of two vector point functions can be found by using the determinant of I bar, j bar, k bar, the first row elements, and del. In the del, what is del? Del means it is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. What is the I bar coefficient? Dou by dou x, that is the first term. Second row, dou by dou y, that is j bar coefficient, that will be treated as second term, and dou by dou z, that is the last term, that is the second row of the determinant. And the last row f bar is f1 I bar coefficient, let it is f bar, this is where f1, f2, f3 are functions of x, y, z. Then I bar coefficient f1, that will be written as a first element, f2, f3. So what this is? This is called a curl F bar. So I can expand this as I bar into dou F3 by dou Y minus dou F2 by dou Z. The I bar into, on finding the determinant I bar into, on discarding the column and row, we'll get I bar dou F3 by dou Y minus dou F2 by dou Z. Minus J bar into, what is the factor? J bar coefficient is, on discarding this column and this row, on discarding you will get dou F3 by dou X minus dou F1 by dou Z plus K bar into K bar, on discarding the last column and first row, dou F2 by dou X minus dou F1 by dou Y. So this is the expansion of the curly F bar. Clearly, this is a vector point function. Vector point function. Curly F bar is always a vector. Div F bar is a, del dot F bar is a scalar. Del dot F bar is a scalar. And curly F bar is a vector. And grad phi is also a vector. Grad phi vector, curly F bar is vector, and divergence of F bar, del dot F bar is a scalar point function. Now, what is the physical interpretation of curl? Suppose if W bar is the angular velocity of a rigid body rotating about a fixed axis, and V bar is the velocity of any point Px, Y, Z on the body, then the angular velocity of the body of rotation at any point is equal to half the curl of the velocity vector, that is W bar is equal to half into curl V bar. Suppose if it is, this is the one rigid body and it is rotating about a fixed axis, some L. And suppose this is the point Px, Y, Z is any point on the surface, then V bar is the velocity of that point on the body. And W bar is the angular velocity. W bar is the angular velocity. Then W bar is equal to half into curl V bar. Or you can write it as 2 omega bar or 2 W bar is equal to curl V bar. This is the relation between omega bar and V bar. It establishes by using the curl of a vector point function. So omega bar is the angular velocity and V bar is the velocity at any point Px, Y, Z on the body. Then the relation between omega bar and V bar is equal to omega bar is equal to half into curl V bar, or 2 omega bar is equal to curl V bar. This defines the relation between W bar and omega bar and V bar, and this is the curl physical interpretation in physical properties. And then the next definition is irrotational vector. A vector F bar is irrotational if curl F bar is equal to 0 bar. Curl F bar, we know that it is a vector. The resultant must be a vector. So curl F bar is equal to 0 bar, not 0. 0 means it is a divergence. Curl F bar is equal to 0 bar. Then the vector F bar is said to be irrotational vector. Suppose if the vector is irrotational vector, then we have one theorem. If F bar is irrotational vector, then curl F bar is equal to 0 bar. And in this case, there exists a scalar potential phi such that F bar is equal to grad phi. So in each and every time when curl F bar is equal to 0 bar for a surface, for a vector F bar, then there exists a surface or scalar function or scalar potential phi such that F bar is equal to grad phi. So that is another result, and there are many application problem also on this result. So please keep in mind this formula. If curl F bar is equal to 0 bar, then definitely there exists a scalar potential phi such that F bar is equal to grad phi. Now, we see some problems on the curl of a vector point function. Suppose if F bar is equal to xy I bar plus yz j bar plus zx k bar, then find curl F bar at the point 1, 2, 3. So just you have to find del cross F bar. Curl F bar means what? The definition of curl F bar is equal to del cross F bar. So given f bar is a vector point function xy I bar plus yz j bar plus zx k bar, and curl f bar is defined as del cross f bar. So first row is I bar, j bar, k bar. Second row, the I bar coefficient of del, that is dou by dou x, j bar coefficient dou by dou y, k bar coefficient dou by dou z. And in the last row you have xy, yz and zx. Right. So on expanding this I bar into, on discarding this column and this row, dou by dou y of zx minus dou by dou z of yz. That is the first term. Minus j bar into, j bar means on discarding the last, second column and first row and second column, you'll get dou by dou, j bar into dou by dou x of zx minus dou by dou z of xy. This is also right. Plus k bar into, on discarding the last row and last column, k bar into dou by dou x of yz minus dou by dou y of xy. So this is the expansion of the determinant when to find the curl f bar. So this is I bar into, we are differentiating partially with respect to y. Here the terms are z and x, so the value will be 0. Here we are differentiating with respect to z partially, dou by dou z of yz, that is y, minus z into j bar into this, see this dou by dou x of zx. So it is also making the partial derivative dou by dou x of x1, the value is z, minus second one is 0. Plus k bar into dou by dou x of yz. These two terms are, when we are differentiating partially with respect to x, y, z, treat as constants. So the constant derivative dou by dou x of yz will be 0, and dou by dou y of xy derivative is the value y1, the value is equal to x. So this is minus yi bar minus zj bar minus xk bar. This is only curl f bar, del cross f bar. So curl f bar at this point, we have to find the curl f bar at the point 1, 2, 3. So on substituting x for 1, y for 2, z for 3, this is minus 2i bar, that is first term. Second term, minus zj bar, minus 3j bar, minus xk bar, minus 1 into k bar, that is minus k bar, which is a vector and which is defined as the curl f bar at the point 1, 2, 3. So in this way you can find the curl f. Curl f means you need to find the determinant of the matrix, determinant of the vectors. And similarly, if you want to find divergence, there is no need of matrix. Just you make the dot product and you can find the result. Now show that, important, curl r bar is equal to 0 bar. This is standard result. Div r bar is 3 already. We have seen in the previous session, we have seen div r bar is equal to 3. So here I am going to show that curl r bar is equal to 0 bar. So curl r bar means del cross r bar, determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. The last row x, y, z. So expanding I bar into dou by dou y of z, dou by dou y of, it is dou by dou y of z minus dou by dou z of y. This is 0, this is also 0. Minus j bar, on discarding this column and this row, dou by dou x of z minus dou by dou z of x, dou by dou z of x. So this is plus k bar into, so on discarding the last column and first row and last column, you will get dou by dou x of y minus dou by dou y of x. So expanding, this is I bar into dou by dou y of, what this is, dou by dou y of z, 0, this also 0, and this 0, 0, 0, all are zeros. So the resultant is 0 bar. So curl r bar 0 bar means what is r bar is, curl r bar is equal to 0 bar, implies r bar is irrotational. Curl r bar is equal to 0 bar, r bar is irrotation. Here not asking, but r bar is an irrotation. We call, if curl r bar is equal to 0 bar, then we can say that the vector r bar is an irrotational. Next we do some examples on this. Find the constants a, b and c if the vector f bar is equal to this is irrotational. So what is the condition if f bar is irrotational? If f bar is irrotational, then what is our condition? Curl f bar is equal to 0 bar. If f bar is irrotational, then curl f bar 0. So if curl f bar 0 bar, then you need to find the constants a, b, c. Right? We'll do the problem. Given f bar is equal to this one, then curl f bar is equal to del cross f bar. Curl f bar means del cross f bar. That is determinant of the first row I bar, j bar, k bar. Second row dou by dou x, dou by dou y, dou by dou z, second row. And the last row, f bar coefficient. This is 2x plus 3y plus az. That is the first term I bar coefficient. Next bx plus 2y plus 3z. And here the element is, you can write here also on erasing, I can write here k bar, and this is dou by dou z, and the last value 2x plus cy plus 3z is equal to 0. So curl f bar is equal to del cross f bar, and this value is equal to 0 bar because r bar f bar is the irrotational vector. Now I'm expanding I bar into I bar and discarding this column and this row. Dou by dou y of this one. Dou by dou y of this one is 2. Dou by dou y of 2x plus cy plus 3z minus dou by dou z of bx plus 2y plus 3z. This is I bar coefficient. I bar this into this of this minus this of this plus k bar into. On discarding the last column and first row, we get dou by dou x of bx plus 2y plus 3z minus dou by dou z of, this is last k bar into these two minus dou by dou y of 2x plus 3y plus az. This is equal to 0 bar. Now what is the values? Dou by dou y of this entire term, that is c only. This is 0, this is 0 because it is function of x and this is function of z. The values will be 0. Minus dou by dou z of the entire term, that is 3 only, plus k bar into, what is j bar? Minus j bar into, j bar term I have not written here. This is, I think, j bar dou by dou x of this 2x. So I am writing j bar coefficient also. I forgotten j bar term. So what is the j bar coefficient? This is dou by dou x of j bar term 2x plus cy plus 3z minus dou by j bar coefficient. This dou by dou z of 2x plus 3y plus az. So minus j bar into, so the second term will be minus j bar into, so j bar, this is dou by dou x of the entire term, only 2. When you are differentiating with respect to x, y term, z term both are zeros. 2x plus 3y plus cz, both are zeros, only x term 2. And here minus dou by dou z of the entire term. Dou by dou z of the entire term is equal to only a. Only dou by dou z of 2x is 0, 3y 0, az means a, plus k bar into, k bar on discarding the last column first row, you will get dou by dou x of this one, that is equal to b. Dou by dou x of this term b minus dou by dou y of this term. Dou by dou y of this is, so what is this is 3 is equal to 0 bar. So what is 0 bar means? 0 bar, 0 into I bar plus 0 into j bar plus 0 into k bar. So that means what? Each equal to 0. C minus 3 0 implies C is equal to 3. That is one constant. Similarly 2 minus A also 0. So A is equal to 2. That is another constant. Similarly, b minus 3, 0. So b is equal to 3. So what are the values? 2, 3, 3 are the constants of f bar, the vector point function, when the vector f bar is the irrotational vector. So if f bar is irrotational, then curl f bar 0 bar, then obviously you can calculate the constants inside the function f bar, that is a, b, c. A is 2, b is 3, c is equal to 3. C also. Now we do some another problem. Show that the vector k is irrotational and find its scalar potential. So in this problem, we need to find first curl f bar. And if curl f bar is equal to 0 bar, then we can decide that the vector is irrotational vector. So after irrotational, you have to find the scalar potential also. So this also we will do by using given f bar. So just we do the step-by-step procedure. X square minus yz I bar plus y square minus zx into j bar plus z square minus xy into k bar. This is the given vector. So if k bar is irrotational, f bar is irrotational, implies curl f bar is equal to 0 bar. So to find f bar is whether it is irrotational or not, we consider curl f bar. Curl f bar is equal to del cross f bar. Del means I bar, j bar, k bar, and this is dou by dou x and dou by dou y, and this is dou by dou z. And the last row, what is f bar? Coefficient x square minus yz and y square minus zx and z square minus xy. So this is equal to I bar into. So I'm discarding last column and first row and first column. Both are first row and first column. Dou by dou y of this one. Dou by dou y of this one is minus x minus dou by dou z of this one. So plus x minus j bar into. So I'm writing on discarding the second column and first row. Dou by dou x of this one. Dou by dou x of this one is minus y minus dou by dou z of this one plus y. So clearly this value also 0 plus k bar into dou by dou x of this one minus z and dou by dou y of this one. This is plus z. So this is equal to 0 bar. Therefore curl f bar is equal to 0 bar. Therefore what f bar is? An irrotational vector. F bar is an irrotational vector. Now we need to show that we need to find a scalar potential phi also. We know that we have one theorem. If f bar is an irrotational vector, then there exists a scalar potential phi such that f bar is equal to grad phi. Now I will go to the next slide. We know that we have, if f bar is irrotational, there exists a scalar function phi such that f bar is equal to grad phi. So f bar, if it is irrotational, then you can find a scalar potential phi such that f bar is equal to grad phi. So what is f bar? f1 I bar plus f2 j bar plus f3 k bar, and it is I bar dou by dou x on the right hand side plus j bar dou by dou y plus k bar dou by dou z, the grad phi. So that is, I can write it as I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So unequating what this is, f1 is equal to dou phi 1 by dou x or dou phi by dou x. Similarly, dou phi by dou y is equal to f2 and dou phi by dou z is equal to f3. But what is f1? What is f1? I will see. f1 means x square minus yz. This is x square minus yz, and this is f2. f2 means what? f2 means y square minus zx, and f3. What is f3? Z square minus xy. z square minus xy. So on comparing both sides, the like terms, I bar coefficient, it is f1, here it is dou phi by dou x, and here it is f2, here it is dou phi by dou y, and here k bar coefficient dou phi by dou z, here it is f3. So on doing comparison, dou phi by dou x is equal to this one, dou phi by dou y is equal to this one, and dou phi by dou z is equal to this one. Also we have from the total derivative, d phi is equal to dou phi by dou x into dx plus dou phi by dou y into dy plus dou phi by dou z into dz by of dz. Or I can write d phi is equal to dou phi by dou x. On comparing, we will get x square minus yz of dx plus dou phi by dou y, that is y square minus zx of dy plus dou phi by dou z, this is f3, that is z square minus xy of dz. So clearly this can be rewrite as x square dx, because dx is the variable of x. So I can write the adjacent of x square. Similarly, I can write y square dy. This is pure separation of variables. Y square terms at the dy side and x terms the dx side, like that. And z square dz. These terms are clear. So I am separating x square dx plus y square dy plus z square dz minus of this yz dx plus zx dy plus xy dz. This is on the left hand side. On the left hand side is this d phi. So d phi is equal to, I can write here d phi is equal to x square dx plus y square dy plus z square dz minus yz dx plus zx dy plus xy dz. So now on integrating both sides, now on taking integration, integral d phi is equal to integral of this term. I can write x square dx separately plus y square dy plus integral z square dz up to this, okay, minus, and this whole thing can be written as d of xyz. D of xyz means yz, if you treat constant, x will be dx plus zx, if we treat as constant, then y dy. Similarly, if x and y are constant terms, then dz. So clearly it is a d of xyz, or I can write x square dx integration x cube by 3, y square dy integration y cube by 3, and z square dz integration z cube by 3 minus. So clearly here integral and differentiable, or both are reverse operators. So we get x, y, z. On the left hand side it is pi. So what is pi? Pi is a scalar potential. And phi exists such that f bar is equal to grad phi. So there exists a scalar potential phi such that f bar is equal to grad phi. So the phi value is x cube by 3 plus y cube by 3 minus plus z cube by 3 minus of x into y into z. So in this case, there are several problems. Finding of curl f bar, and similarly showing of the irrotation vector or not. Suppose if it is irrotation vector, find the scalar potential, and there are different finding of scalar potential phi. Next, there are several properties also there. We will discuss in the next video. And here we do another problem. One property, like it is a property. Prove that if r bar is the position vector of any point in the space, then r power n into r bar is irrotational vector. Or we have to show that curl r power n into r bar is equal to 0 bar. So very simple. So we know that r bar is the position vector of any point. Suppose if p, x, y, z, b, p, x, y, z, b, any point on the space. then R bar is equal to xi bar plus yj bar xi bar plus yj bar plus z into k bar, R bar. And what is R? The standard formula, R means magnitude of R bar, that is right square root of x square plus y square plus z square. R is nothing but magnitude of R bar. And what is dou R by dou x? Dou R by dou x is equal to x by R. So how you will find dou R by dou x? I can write dou R by dou x, the derivative of this 1 by 2 root of x square plus y square plus z square into 2x. So 2 cancel, the value is equal to x by R. Similarly, dou R by dou y, that is equal to y by R. Dou R by dou z, that is equal to z by R. So we have calculated all the requirements. Now, R power n into R bar. R power n into R bar. R power n. R is a scalar function. R power n is also a scalar point function. R bar is a vector point function. So, do as it is, R power n as it is. And R bar can be written as xi bar plus yj bar plus zk bar. R I can write is I bar coefficient x into R power n plus j bar coefficient y into R power n plus k bar coefficient z into R power n. K bar coefficient z into R power n. So clearly R power n into R bar is also a vector point function. Now to show that R power n into R bar is irrotational, we need to show that curl del cross R power n R bar is equal to 0. So R power n into R bar is irrotational, or curl R power n into R bar is both are same. Now to prove this result, I consider curl R power n into R bar. Now consider curl R power n into R bar. That is del cross R power n R bar. So what is del cross? We know that I bar, j bar, k bar, and dou by dou x, dou by dou y, dou by dou z. Next, R power n into R bar. Already we have seen the function R power n into R bar. That is x into R power n into I bar plus y into R power n into j bar plus z into R power n into k bar. So I am writing x into R power n, y into R power n, z into R power n. So this is curl R power n into R bar. So this is I bar into dou by dou y of this one. Dou by dou y of, I can put sigma also. No need of expanding each and every term. I am using the sigma notation and I am writing only the I bar coefficient. Dou by dou y of z into R power n minus dou by dou z of y into R power n. Dou by dou z of y into R power n. So this is summation I bar into dou by dou y of this one. Z as it is n into R power n minus 1 into dou R by dou y. So the differentiation partially with respect to y. This is z term. So z constant, R power n derivative n into R power n minus 1 into dou R by dou x minus dou by dou z of this one, the partial derivative of z, this function with respect to z, y constant, R power n derivative with respect to z n into R power n minus 1 into dou R by dou z. So that is summation I bar into z n R power n minus 1 dou R by dou y. What is dou R by dou y? Dou R by dou y is y by R minus y into n into R power n minus 1 dou R by dou z. This is z by R. Dou R by dou y is y by R, dou R by dou z is z by R. Now this is summation I bar into, so z n, so R power 1 in the denominator, I am writing R power n minus 2, here n into y into R power n minus 2 into z minus, here also y into n into y into R power n minus 2, R power n minus 2 into z, r power n minus 2 into z. N into y into r power n minus 2 into z. So clearly this is, and this are both are equal terms, that is I bar into 0, that is equal to summation 0 bar, or this is 0 bar. So curl r power n into r bar is equal to 0 bar, is equal to 0 bar, implies r power n into r bar is irrotational. R power n into r bar is irrotational vector. There ends the proof of the theorem. Similarly, we can do several problems on curl of a vector point function. And in the next video, I will define the del of del. Del of del means it is called the del square, that also having some properties. Del square, Laplacian operator, del square 0. Del square means dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So in this video, we have seen the rotation vector and finding of scalar potential phi, and showing of curl r bar is equal to 0 bar, and different problems based on the curl f bar we have done. So with these few words on curl of a vector point function, I conclude my class, and I will see you in the next class.
Like, share and subscribe. Hit the bell icon for more updates.